For many months, the water level of Lake Okeechobee was steadily lowered under a fully approved plan. On the surface, the lake simply appeared smaller, much like it does in other years. But when cameras began recording close to the waterline and footage was compared day by day, something else started to stand out. As the water retreated further, the lake bed did not remain still as many people had assumed. Dark patches appeared, stretched outward, then slowly shifted toward the remaining water, leaving behind strange marks that changed continuously. At first, they looked like dried mud, but when images were placed side by side, their shapes were anything but fixed. An entire underlying layer seemed to be sliding as the familiar holding force disappeared. What made many people begin to pay attention was that Lake Okeechobee is not just a lake. It sits at the center of Florida's water supply system. What is moving here connects directly to drinking water, food prices, and the cost of living for millions of people. The question is no longer how much water has been removed. The question is what has begun to shift underneath, while most people never thought to look down.
Most people assume that when water levels drop, a lake simply becomes smaller. But Lake Okeechobee does not behave that way. It is a very shallow lake. In many areas, the average depth is only about 9 to 10 feet. So when the water level is lowered by 4 feet, a large portion of the lake is fundamentally altered. Sunlight begins reaching areas of the bottom it never touched before. Wind stirs up sediment in new ways. Water temperatures shift more rapidly between day and night. Together, these changes disrupt the stable rhythm the lake once maintained. These changes were not announced loudly. They were first noticed by people living around the lake. Boat ramps began running dry earlier than usual. Some access points became difficult to use even before peak season had ended. Fishermen observed fish crowding unusually into the remaining deeper waters. Wading birds appeared in greater numbers. Alligators gathered around the last pockets of water. These are often signs that living space is being compressed, forcing wildlife into shrinking areas where conditions remain viable. But what people could see on the surface was only the most obvious part. As the water level continued to fall, the shape of the lake bed itself began to change in ways that made longtime residents uneasy.
Large, dark areas appeared where open water had once been. The boundary between water and mud did not stay fixed, but shifted day by day. In some places, long streaks formed across the exposed bottom, as if something heavy had slid through when the water above was removed. This raises a question many would rather avoid. In a shallow lake like Okeechobee, water is not just habitat. It also acts as a natural layer of compression. The weight of the water keeps sediments, nutrients, and materials that have accumulated over decades settled on the bottom. When that pressure is removed too quickly, the lake bed does not simply emerge and remain still. It must adjust to sunlight, wind, and the remaining currents in ways that cannot be fully observed from the shoreline. What has begun to worry many people is that everything happening is technically within procedure. There were no secret decisions, no illegal actions, no alarms sounded. But when a large ecosystem starts responding differently after an adjustment deemed reasonable, the issue is no longer simply whether the water level is high or low. The real question is this: when the water layer is removed first, what begins to move beneath it? And will those quiet movements stop once the water level rises again? Because in large systems, the most concerning changes are often not what disappears, but what begins to emerge when the familiar covering is no longer there. 2. A safe water decision that quietly changed everything. The decision to lower the water level of Lake Okeechobee was not made during a crisis. It did not come from an emergency meeting, nor was it a reaction to an extreme weather disaster. In fact, this was a pre-planned decision, fully documented in official operating records, complete with timelines and clearly defined figures. On paper, it was described as a necessary adjustment to keep Florida's largest water system operating safely and reliably. Those responsible did not refer to it as draining the lake. They called it water level management. The goals were laid out clearly: reduce pressure on the levee system, create capacity for heavy rainfall in the future, give the lake's ecosystem a chance to recover after years of strain. Reading through these documents, it is difficult to find anything that sounds dangerous, and that is precisely what made many people uneasy. The decisions that carry the greatest long-term risk rarely feel risky at the moment they are made. When everything follows proper procedure, no alarms sound, no urgent headlines appear. Water is released in an orderly way, exactly according to schedule. For most of the public, there is no obvious reason to stop and ask questions. But the system that governs Lake Okeechobee has never been simple. This is not just a lake, it is the center of a highly complex water control network that serves structural safety, agriculture, cities, and the environment at the same time. In management models, lowering the water level by a few feet brings several key indicators back into what is considered a safe range. On a spreadsheet, it looks like a reasonable choice. The problem is that spreadsheets do not see the lake bed. Lake Okeechobee is shallow, and that makes it respond very differently to changes in water level.
When the water is lowered quickly, the bottom does not have time to adjust gradually. What happens below follows physical and ecological laws, not administrative schedules. Sunlight, wind, temperature, and weak remaining currents begin interacting with sediment that has accumulated for decades. This part of the story is rarely stated plainly in management documents. In theory, lowering the water level is considered beneficial for the ecosystem. Many plans are built on the assumption that when water is lower, the lake bed stabilizes and more natural conditions return. But that assumption only holds when the underlying system is still balanced enough to respond as expected. When the water layer that acts as a cushion is removed too quickly, the baseline condition of the entire lake changes at once. The paradox is that the more closely this decision followed procedure, the less dangerous it appeared. There were no visible signals forcing public attention. But for those living near the lake and downstream, the unease did not come from a sudden incident. It came from the sense that the system was now operating in a different state where reactions not written into official plans were beginning to appear. And this is the central issue with Lake Okeechobee. The question is not whether lowering the water level was right or wrong. The question is, when a decision looks reasonable on paper, who becomes the first to live with the consequences that were never written down? In large systems, responsibility rarely ends where a decision is made. It often flows with the water toward places with less voice and fewer options. When water leaves the lake, risk does not disappear. It changes form. And in the next part, the reactions beneath the receding water began to come into sharper focus. No longer just a vague concern, but physical movements that cameras are able to capture. Footage revealed the lake bottom was no longer stable. At first, most people assumed Lake Okeechobee was simply exposing its bottom. When water recedes, mud appears. When mud dries, its shape changes. That sounds ordinary enough, but then the footage began to show something different. Not something still, but something moving. In some areas, the surface of the lake bed did not hold the same shape from one day to the next. Wide, dark patches appeared and then vanished. The boundary between water and mud shifted so quickly that it was hard to explain by simply saying the water was slowly receding. In certain places, the mud looked as though it had been dragged, leaving long streaks pointing toward the remaining pools of water. These movements were not fast. They were not violent, but they were slow and heavy enough to feel unsettling when watched for long periods, as if a deeper layer beneath the surface was sliding once the water above was no longer holding it in place. What stood out was that this was not happening in just one isolated area.
It was recorded in multiple locations around the lake, miles apart. People familiar with the lake began to realize this was not ordinary mud behavior. When mud simply dries out, it cracks, shrinks, and stays in place. What the cameras captured looked more like large, heavy masses shifting together, not a thin surface layer pushed by wind. At the same time, changes on the water surface became more pronounced. Fish continued crowding into deeper areas, but now it was more than density. In some zones, nighttime oxygen levels dropped, forcing fish to rise closer to the surface. Wading birds gathered in unusually large numbers around the remaining fish concentrations.
All of these signs pointed to an ecosystem being compressed, not only horizontally, but vertically. As water recedes, living space does not shrink evenly, it collapses, and when that happens, everything below is forced to compete within an increasingly limited space. Then another concern emerged. The dark, moving areas were not staying fixed on the bottom. They began drifting closer toward the remaining water, as if being pulled along by weak currents still present in the lake. Some footage showed these masses carrying mud, debris, and small organisms with them, forming dense clusters that moved slowly but continuously. That raises an uncomfortable question. For decades, the bottom of Lake Okeechobee has accumulated many things: sediment, agricultural nutrients, decaying plant matter. All of it remained relatively stable because of the water above. When that water is removed faster than usual, those materials do not simply remain where they were. Longtime observers of the lake began saying quietly that this was the lake rearranging itself. But this rearrangement does not resemble a slow recovery. It looks more like a heavy mass sliding toward the lowest point, carrying everything in its path. What many people are not prepared to face is that this movement does not need to be fully visible to become dangerous. The moment it becomes clear that the lake bed is no longer stable, every assumption that the water will return and everything will return to normal becomes fragile.
At this point, Lake Okeechobee is not just responding to low water, it is responding to the loss of the pressure that once held it in place. And when a large ecosystem loses that familiar holding force, the first things to move are rarely the most visible ones. They're the heaviest, the quietest, and the hardest to control. What the cameras recorded during this phase does not explain the entire story, but it is enough to raise a clear concern. If the lake bed has begun to move as the water recedes, what happens when those movements continue closer to the rest of the water system? And that is where the story enters a new phase. Because what is moving beneath the lake does not only reshape the lake itself, it may also reshape what happens when the water eventually returns. 4 scientists identified what was actually moving below. By this point, many people had begun guessing what they were seeing at the bottom of Lake Okeechobee. Some believed it was simply mud being dragged as the water receded. Others thought it was dead vegetation drifting away. But for those familiar with the structure of this lake, the answer was not a single object. What was moving was the foundation itself. For decades, the bottom of Lake Okeechobee has accumulated a very particular mixture: fine sediment, decomposed aquatic plants, nutrients carried in from agricultural runoff, bird droppings, and fish waste. Together, these materials form a soft, heavy, organic-rich layer commonly referred to in scientific literature as muck. Under normal conditions, this muck layer is kept relatively stable by the weight of the water column above it. When the water level is lowered quickly, that stabilizing condition disappears. Sunlight dries and shrinks the surface.
Wind creates constant disturbance. Weak remaining currents begin acting directly on a layer that had long remained still. As a result, the muck no longer holds its original position. It begins sliding as a mass, much like a heavy carpet losing its grip. What makes this concerning is that the muck is not inert mud.
It contains large amounts of phosphorus and nutrients that have been trapped for many years. When this layer is disturbed and begins to move, those substances can be released back into the water column. This does not always happen immediately, but it creates the conditions for much stronger biological reactions once the water returns. In other words, what is moving beneath the lake is not only reshaping the physical structure of Lake Okeechobee, it is redistributing a massive biochemical reserve that has built up over decades. And when that reserve is stirred, the consequences rarely remain confined to the lake bed. This is why many experts have long warned that rapidly lowering the water level in a shallow lake like Okeechobee always carries risk, not because the water is low, but because the foundation loses stability. When the foundation becomes unstable, the assumption that everything will return to normal once the water comes back becomes very fragile.
It is important to note that this muck layer is not new. It has been there for a long time, forming alongside the history of human intervention in the lake's water system. While it remained undisturbed, most people gave it little thought. But once the water receded and the foundation began to shift, what had been buried suddenly became the central factor in the story. So what the cameras captured beneath Lake Okeechobee is not the sign of a new threat, but the sign of something that already existed and has now been awakened. Lowering the water level did not create the muck, it simply removed the only thing that had been holding it in place. And from here, the question moves beyond the lake bed. When what was once buried begins to move, where does it go next? And who will be the first to live with the consequences of that movement? 5. When lake changes started reaching homes and water bills, what began moving beneath the bottom of Lake Okeechobee does not stop at the boundaries of the lake. That is rarely how a water system of this size works. Lake Okeechobee is not an isolated body of water. It sits at the center of a network of canals and flows that connect directly to downstream communities. When the lake bed loses stability, the question is no longer only what is happening inside the lake, but what will be carried along once the water begins moving again. One of the biggest concerns involves nutrients. The muck layer contains phosphorus that has been locked in place for years.
When this foundation is disturbed and redistributed, those substances can return to the water column. What is notable is that the impact often does not occur when water is low, but when water rises again. At that point, what once lay dormant can fuel stronger biological reactions. For downstream communities, the effects rarely appear as a single dramatic event. They arrive slowly, but they linger. Water becomes murkier in phases. Treatment costs increase. Unusual tastes or odors appear and disappear. For many households, this is not an abstract scientific issue. It shows up in water bills and in the quiet uncertainty of turning on the tap each day. Agriculture experiences the shift in a less visible way. Water carrying higher nutrient levels can affect soil and crops over time, not within a single growing season, but across many cycles. Changes like these are difficult to trace back to one cause, but they accumulate gradually, much like the muck itself accumulated on the lake bed. Fisheries and wildlife are often the first to respond. Fish, already crowded into smaller spaces during low water, now face more volatile conditions as levels rise and fall unpredictably. Low oxygen, cloudy water, and rapid changes in habitat make many areas harder to anticipate. The key point is that no one in this system intended to create these outcomes. The original decisions were made to reduce risk, but in complex systems, reducing risk in one place often means shifting it somewhere else, farther away and less visible. And that is where the real question emerges. Not whether Lake Okeechobee is too low, but who will be the first to live with the quiet consequences that began at the bottom of the lake. Because water does not carry responsibility. It carries whatever has been disturbed along its path.
6. What happens after water returns but damage remains?
When the water level in Lake Okeechobee begins to rise again, many people assume that everything will be fine. The lake widens, exposed mud disappears from view. For much of the public, that is often seen as the end of the story. But in large water systems, the return of water does not mean everything resets. What shifted beneath the lake does not automatically move back into place just because water levels increase. The foundation has been rearranged. Materials that were once locked down have been redistributed, and ecological reactions triggered during low water often continue influencing the system afterward, slowly and quietly. This leads to an uncomfortable reality. In systems that have been adjusted for decades, like Lake Okeechobee, every reasonable adjustment leaves a mark. Not immediately, not always visibly, but the effects accumulate, and eventually the system begins responding in ways that fall outside any plan. Lake Okeechobee stands out only because its scale is large enough for cameras to capture the changes. What is happening here is not unique. Shallow lakes, controlled canals, and wetlands elsewhere operate on similar assumptions. Reduce risk in one place, trust that the rest will stabilize on its own. The question is, stabilize in what direction? For residents, the consequences do not arrive as a single disaster. They appear as rising costs, shifting water quality, problems thought to be resolved returning in different forms, and a growing sense that decisions shaping their daily lives are being made far away.
Water can be removed and later restored. But what is awakened when the water leaves does not always settle back down the way it once did. And that is what remains when the surface of the lake appears calm again. Thanks a lot for sticking with us till the very end. If you found this video useful, make sure to hit that like button and subscribe so you won't miss any of our daily uploads. And now, go ahead and explore some of our top recommended videos popping up on your screen. Goodbye, and see you in the next.